Okay, folks, these are the notes for 9.3. We're talking about properties of similar triangles here. Now, don't forget that similar means that the angles are congruent and the sides are proportional. The angles are congruent and the sides are proportional. So let's take a look at example 1. Constructing a line parallel to a side of a triangle. So normally I would have you guys do this with your compasses, but you guys are in luck because it's just the video today. The compass is to construct a line parallel. That's the little construction that we use. It had an arc right here, and then you put another dot right there, and then you swing your arc through this way. Hopefully this should look a little bit familiar to you. And then we take those 2 points where these guys intersect, and then we would measure the distance between that and that with our little compass. We would take this point where the arc and the side intersect, and then measure that distance all the way over there, find where that distance stops, and then run a parallel line through there, through those 2 dots. Now, you guys don't have to do that. I'm just kind of showing you, trying to remind you what that construction is, but don't worry about it. You won't have to do that for a test. Okay, triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other 2 sides, then it divides the 2 sides proportionally. I will tell you, you may hear my kid in the background. He is sick today, and so that's why I'm making this video. Alright. Example 2. In the figure to the right, we have QP. I'm looking at what this means right here. We've got QP is parallel, it looks like, to TS. And QT equals 4. TR is, here, let's move this a little bit. TR is 2. PS is 6. And we're trying to find the length of SR here. Well, since it divides these guys proportionally, then we can just create a proportion from this. And for this, I'm just going to take the lengths on this side, and then kind of bring them over here, and I'm going to say 6 over x, and then I'm going to take the lengths of this side right here, bring them over here, and say equals 4 over 2. So we're just looking at the side segments. So 6 over x equals 4 over 2. And then, of course, I cross multiply. 6 times 2 is 12 equals x times 4 is 4x. And I divide both sides by 4. These 2 4's, they cancel out, and that just gives me x equals 12 divided by 4 is 3. And so I know that SR over here equals 3. Now I can check that really quickly. I can say, all right, well, I've got 3 over here, 6 over here, and I know that 3 is half of 6, right? 3 is half of 6. Well, is 2 half of 4? Yeah, 2 is half of 4, and 3 is half of 6. So I know that those guys are proportional. All right. Let me erase some of this stuff. Let's go to example 3. Example 3 says, find the value of x and y. So here's my x, here's my y. And so all of these triangles should be proportional if we have these two parallel lines. So those angles are equal, those angles are equal. So we know that all these segments are proportional. Okay. So remember from the very beginning of this lesson that if a line parallel to one side of the triangle intersects the other two sides, then it divides the other two sides proportionally. We've got a line parallel to the other side, to the one side of the triangle, so it divides these two sides proportionally. So I can just take this side and I'll say 16 over 5, and then I'll take this side and I'll say equals 20 over y. I cross multiply, I get 16y equals, and then 20 times 5, well, 20 times 5 is 100. So I divide both sides by 16, and I get y equals 100 over 16, which is 6.25. So I know that y is 6.25 over here. Now I'm asked to find our x. So I've got to find x over here. Well, here's the thing, is that I still know this proportion right here. And this, if I know that proportion, I can use it for any of the sides or even the perimeters. I can use that same proportion. So I'm just going to set up that same proportion. 16 over 5, once again, it just comes from right there, boom. And then I'm going to set it equal to this, x over 35. But hold on. I can't actually do that. Now why? Here. Take a look at what 16 is and what 5 is. So 5 is just a segment of this, right? 5 isn't the whole side. Now, that was fine when we were comparing little segments. Now, here's what I'm talking about. When we compared 16 over 5 to 20 over y, well, we were just comparing segments, right? But 35 is the whole side of the triangle. It's not a segment, it's the whole side. We're comparing a whole side to whole side. So I need to set up my ratio a little bit differently for this. So I'm going to draw my big triangle over here. X, C, B. This side is 35. This side is, we said y was 26.25, so this side is 26.25. And XC over here, it's 16 plus 5, which is 21. So now I'm comparing two triangles, X, Y, Z, and XCB, right? So I'm going to put small over large, 16 for my small triangle, and then remember 21 for my large triangle, and then small is X over, and 35 from my large triangle. So just to be clear, this side and this side are corresponding. That's why I can put one over the other, right? Same side, just different triangles. Then I can say equals to this side and this side are also my corresponding sides of my triangles. They're the same sides of different triangles. That's why I can put one over the other over here. Alright, and now I just cross multiply, so I get 16 times 35, which is 560, equals 21 times X, and then I divide both sides by 21, and I get X equals 26.6 repeating. So I know X is 26.6 repeating like that. Alright, so when you're setting up your proportions, you've got to be careful about what you're comparing to what. If you're comparing a full side to a full side, you need to make sure that this guy, the ratio that you use, is also a full side to a full side. But if you're comparing two segments to two segments, all you need to do is set up the ratio that has those two segments. Okay, it can be a little bit confusing. So let's take a look at the two transversal proportionality theorem. That is displayed by this guy right here. Well, how many parallel lines do we have in this? If 3 or more parallel lines intersect two transversals, and remember, a transversal is basically just two lines hanging out, these two transversals right here. Then they divide those transversals proportionally. Alright, so that means that CB over AB, it's going to be proportional to DE over EF. Those two guys are going to be proportional. So just to put that in an equation here, we've got CB over AB is equal to DE over EF. So now we have example number 4. Alright, and just because of my program, I've got these wonky little things all over the place, but let's see, let me try to figure this out. LI is parallel to MJ, is parallel to NK. And so we're asked to find LJ. m right here. Okay. Well, I'm just going to look at this side right here, and I see that I've got LM, I've got LM is x, and MN is 12. So I'm just going to say x over 12 equals, then I'm going to take a look at this side. I see that IJ is 5 and JK is 9. So I can say equals 5 over 9. Now how can I set this up? How do I know? Because when 3 or more parallel lines intersect two transversals, they divide those transversals proportionally. So if it's proportionally, you can get this. Now I just cross multiply. 9x equals 12 times 5, 60. I divide both sides by 9. And I get these two 9's cancel out. So x equals 6 repeating. Alright? I'm not sure why they're throwing all these decimals at us today, but that's the deal. Alright, so turn the page. We'll look at the triangle-angle bisector theorem. Boom! Okay? Triangle-angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are, it's our favorite word, proportional to the lengths of the other two sides. Okay, so what does that mean? Let's look at this guy right here. So this ray is bisecting this angle, right? Which means that angle ABD is going to be congruent to angle CBD. Alright. And so that means that these guys, this side and this segment, are going to be proportional to this side and this segment. Now, we like to call this, now, I know we don't like to talk about rams that much here at Pierce, but we like to call this our little ram here, because we know that this, here, let me put a couple of dots right there, just for fun. We know that this side over this side is proportional to this side over this side. And you see our little ram? You don't? Here, let me help you out. Alright, so there's our ram. So let's put that little guy to use here. So here we have an angle that is being bisected by a ray, just because I'm going to put my little nostrils down here, alright? And we're asked to find xy, this guy right here. Now I know that xy over yw is going to be proportional to xz over wz. Here, how about this? This will be a little better. Okay, that's a better looking ram. So I'm going to do my proportions here. I'm going to take x, y, and I'm going to say value of x, y is x, right, over y, w, 4, equals xz, which is 10, over zw, which is 7. And so I just cross multiply those guys. I get 7x equals 4 times 10, 40. And so divide both sides by 7, and I get x equals 5.71. We will round to the nearest hundredth on that one. All right. I want you guys to try example number 6 here. Find the value of x, and I'll help you out with this one. If we know that this is x and the whole length is 7, then use your part plus part equals whole here to figure out what this is. If this was, let's say this was 3, then what would this be? This would be 4, right? Or 7 minus 3. So your value of this side is 7 minus x. So go ahead and set up a proportion for that. Take 30 seconds just to set up the proportion. I don't even want you to solve it. Just set up the proportion. Go ahead and pause this and we'll set up the proportion. Pause it now. Alright. So hopefully you set it up as 9 over x is equal to 12 over 7 minus x. And then we just solve it the same way. Don't let those two x's scare you. Now we've got 9 times 7 is 63, and 9 minus x and times negative x is minus 9x equals 12x. And there's our 12x. So we just combine our like terms, add 9x to both sides, and then we get negative 9x and positive 9x. Of course, that's equal to 0, so we're just left with 63 over here. And then 12x plus 9x is 21x. Now I divide both sides by 21 to get that equal to 1 here. Divide 63 by 21, and there we go. There's a nice normal number. X equals 3. Alright, so what I want you to remember from this is that even if you don't know the segments, you can take a look and then just try to figure it out from what you know about your part plus part equals whole. Okay, example number 7 says find the value of x for which a, b, c, and that's a, b, c, is proportional to e, d, a. EDA. Now see, EDA is all kind of flipped over here like this, and we've got E, D, A, and I don't like it when I have stuff like this where where my triangle is upside down. So I'm just going to take my triangle over here and flip it over here like that. Ah, so much better. Okay, so now I'm going to take my D and I'm going to put it up here. I'm going to take my E, which I notice is like opposite the small side. It's just across from the small side. And then I know that my A is across from the hypotenuse for this, so A is that way. EA is X. ED is 4. And DA is 6. You always have to be really precise when you're flipping the triangles and drawing them over again. So now I know that these guys are proportional, right? My two triangles, or at least I'm trying to make it so that the value of x makes these two guys proportional. Well, what do I know for this triangle for AC? What is the length of AC? Well, I know that this side, CE, is 4, right? And I know that EA is X, so together they're just 4 plus, here, I'm going to, 4 plus X. Alright, so first I have to set up a proportion, and I'm going to go with dA over BC. Remember, when you're setting up a proportion, you're going to look for two sides that have numbers. Okay, two sides with just numbers. So I'm going to do small over large. Small over large. So that means my small triangle. This is my small triangle over my large triangle. And so I've got my 6 right here. I'm going to bring that down. Whoa! Goodness. Bring that down over this way. And then I've got my 9 right over here. And I'm going to take that down to this. So I've got my small over large, right? And I'm going to set that equal to my hypotenuse. That's my small. I'm going to bring that down here. Over my 4x. Let's see if I can get that to be. There we go. So now I've set up my proportion. And I can cross multiply. And I get 6 times 4, which is 24, plus 6 times x, which is 6x. And then I cross multiply the other way. That's much easier. That's just 9x. Alright? Now, if you're confused about what I just did, you can ask the teacher to rewind this video and then look again at it. Any takers? Okay. So I'm going to subtract 6x from both sides, and 6x minus 6x just gives me 0, so I get 24 is left over. 9x minus 3x minus 6x is 3x. And then I divide both sides by 3. So I get x equals 24 divided by 3 is 8. So I get x equals 8 over here. And I can check it if I want to. I know that my EA was x, so I can put 8 over here. I know that my new side for AC is going to be 8 plus 4, which is 12. And so I can say my ratio was 6 over 9. Remember, I just got 6 over 9 equals 8 over 12. 8 over 12. And I can reduce those both down to 3, oops, sorry, not 3, 2 over 3 is equal to, because I divided this 6 by 3, I got 2. I divided 9 by 3, I got 3. I can divide 8 by 4 and get 2. And then I can divide 12 by 4 and get 3. So it works out. This reduces down to this right here. And I know if, like, I've got my two ratios for my sides, if I can reduce them down to an equal fraction, I know my sides are proportional. Okay, I know that we have covered a lot of stuff very quickly. Hopefully I didn't confuse you too much. You can always go back to this video on my YouTube page, but go ahead and do the first page of your homework, just first page, and then that I want you guys to make sure you bring that homework in tomorrow, because tomorrow we are going to do the group work on that second page, but that's going to be tomorrow. All right. Oh, by the way, I'll check your homework from yesterday. I'll check that tomorrow. Thanks.